Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday Night Math Night. I am excited to be back. Like Dr. A said, my name is Amy Sink, and I am one of the math specialists here at the Learning Liaisons. My voice is shot. We had lightning dismissal at school today because we live in Florida. And so between just the first 2-week exhaustion and talking all day to lightning dismissal and having to use my voice more than I normally do, my voice is shot. So we're going to power through this, y'all. I was not here last week because I am an administrator here in Central Florida, and we just had a lot of back to school stuff going on, but I am happy to be back with you. I absolutely love that I get to do this. This is my pride and joy. This is what I love doing on the side, is just being able to help you understand that math and understand what those misconceptions are. In fact, I spent a good portion, I'm trying to find my presentation so I can put it up here. I spent a good portion of today in a math classroom, actually, just helping the teacher and giving her feedback and all of that, which, y'all, I just love doing that. And coming at it from a place of like love and care, because being a teacher is not easy, but it's truly a calling for so many of us. And so I just love supporting teachers. Anyways, that was like that is not even the right presentation. That was a total rabbit trail. So we are going to do about 10 problems today. They are 6 through 12. And I am not understanding why my presentation is not here. So that's fun. They are 6 through 12. And so we are going to go through the whole gamut. In the comment box while I'm trying to find my presentation, let me know where you're from. What test are you prepping for? Because that'll help me understand like what rabbit trails we're going to use tonight. So where are you from? What test are you prepping for? And what is the get to know? I always do a get to know you question because it just makes it feel a little less, computer screeny and a little bit more like we're doing math in my living room. So where are you from? What test are you prepping for? And are you guys watching the Little League World Series? That's going to be the question. Are you a baseball fan? And are you watching the Little League World Series? Just a town or two away from us, their Little League team is in the World Series. Like, they're like competing for it. They are one of the top, I think, 4 United States teams at this point. And if they win tonight at 7:00, then they get to keep going. So that's super fun from like a little, small town kind of thing. It's super fun to see them doing so well. So yeah, where are you from? What test are you prepping for? And are you watching the Little League World Series, or at least just keeping up with it? Like, we may not sit and watch the entire game, but are you at least keeping up with the Little League World Series? All right. Eventually, we will get this presentation locked and loaded. I don't understand why it's not showing up. If you've been around long enough with me, you know that sometimes we just have iPad issues and tech issues. So I'm going to try one more thing, and then we're just going to go old school. So let's try this. Bingo! Winner, winner, chicken dinner. Okay, here we go. We can do this, y'all. Are y'all having a good week? That's what I want to know. Are you having a good week? Because I am. You're not a fan of the World Series. Totally understand. I get it. Quite frankly, I couldn't tell you much about the World Series. It's just super fun that our kids from a local town are in it. You don't have to apologize for that. Probability. Okay, I will definitely add probability problems into the upcoming weeks. I pretty much always have Praxis 7813 problems. I pretty much always have K-6 problems. Probability is kind of, one of those things that sometimes we do and sometimes we don't. So I will absolutely add probability in here. This is my next couple of weeks running list. And so this is kind of where I will include like upcoming topics. So if there's something that you want to see, I always keep Praxis 7813 on here, just because we have people that are taking that exam that show up every week. And so I always like to make sure that I've got problems for them. And I always like to make sure I've got some K-6 problems as well. But if there's something specific that you're struggling with, let me know, and I will absolutely add it to the upcoming weeks here on this slide deck. All righty, let's go ahead and move on to problem number 1. Here we go. Which of the following values satisfies the given equation? Which of the following values satisfies the given equation? Okay, so there are 2 different mindsets of how we can solve this. One, we can solve it algebraically. Absolutely. 2, we can use our answer choices to help us. So we can approach this in one of 2 ways. We can solve it algebraically. So I'm going to put algebraic. And 2, we can use our answer choices. I am going to solve this problem both ways, because even if you don't need to know exactly like this concept, like my elementary people, you probably don't need to know this, right? Knowing how to use your answer choices to help you is definitely a great skill for you to know how to do. And so this may not be the type of problem that you have, but you definitely may want to know what those answer choices look like. All right, so number 1, algebraic. So this is actually supposed to be a squared, not a cubed. So actually, it doesn't matter. So I take that back. As I'm looking at this, algebraic is not possible. Here's why. Because we have an x cubed and then an x, and then a constant. And to solve that for 0 is really almost impossible. Now, I'm pretty sure this was supposed to be a squared. So why is my writing not showing up on this screen? Can you guys see my writing that I'm doing on the screen or no? Because that is not good if you can't see the writing. Like, it's kind of useless if we can't see the writing, right? So there it is. That was weird. It like all appeared at once. Okay, let's see if it like keeps up with me. It's not like I'm literally writing on the screen and it's not keeping up at all. I don't understand. Okay, we're going to do this. We're going to scratch this. We're going to discard that. We are going to stop sharing the screen. And now we're going to restart it and see if that works. That was so weird. I have never had that problem, y'all. Like, I've had all sorts of problems with this silly iPad, but we've never had that. So that was weird. Okay. Here we go. Window, share. Let's see if it'll keep up now. There we go. Woo, woo. Woo, woo. Okay. So which of the following satisfies the given equation? So we cannot, yes, Tanya, you're my favorite person right now. This poor iPad is like, y'all, it's the first week of school. I'm done. It's just as tired as I am. Okay, so we cannot solve this algebraically because it's really going to be almost impossible to solve this algebraically. Could we do it? Probably, but not worth it. Now, I will show you how to solve it algebraically if that was a square, because I think it was supposed to be. But if not, then, or I'll show you how to do it if it was a square. How do I use my answer choices? Well, I'm literally just going to plug in each of these answer choices into my X values, and it's going to spit an answer out, and we can see if it's true or not true. So let's see what that looks like. 3 times -1 cubed plus 2 times -1 minus 5 is greater than 0. 3 times -1 cubed is -1 because -1 times -1 times -1 is -1. Negative times a negative is a +1 times -1 equals -1. That was a whole lot of negatives and positive ones. So I'm left with -1. 2 times -1 is -2 minus 5 is greater than 0. I don't even need to keep going. Here's why. Don't waste your time on things that don't matter, because your time is so valuable when we're taking these tests. So if you waste your time on things that don't matter, you're going to just waste your time. I can already see I have a -3, and then I'm subtracting 2, and then I'm subtracting 5 more. I'm just going further and further and further into the abyss of the negatives, and that's not going to be greater than 0. So this is not going to be true. It's not going to satisfy that equation. Now we're going to do the 0. Now we're going to do the 0. Three times 0 cubed plus 2 times 0 minus 5 is greater than 0. 0 cubed is 0. 0 times 0 times 0 is 0. So 0 times 3 is 0, because 0 times anything is 0. So this is 0 plus 0 minus 5. -5 is not greater than 0. So this is not true either. 1. 3 times 1 cubed plus 2 times 1 minus 5 is greater than 0. 3 times 1 cubed, 1 times 1 is 1, times 1 is 1. Do not mistake 1 cubed for 3. This does not equal 1 times 3. 1 cubed equals 1 times 1 times 1. 1 cubed does not equal 1 times 3. And that is a common error with our students and with teachers when we're going too quickly. So if it asks you for a student error, this right here is going to all day be a common student error. So 3 times 1 is 3, plus 2 minus 5 is greater than 0. 3 plus 2 is 5, minus 5 is greater than 0. 0 is not greater than 0. So that is incorrect. And we can see that our answers are getting smaller and smaller and smaller in the negatives, and eventually they're going to become positive. And so then, or the negatives are getting, the value is getting bigger. The negatives are getting, the digits are getting smaller. And so I already know without even solving it by using a little bit of logic that D is going to be the right answer because it is going to satisfy that equation. Does that make sense? Okay, so if you have questions while we are working out any of these problems, you can always ask. I am monitoring the comments as we are working these out, so don't hesitate to ask questions. Bruce, you said no. No, it doesn't make sense. No, you don't agree. No, you don't need me to solve anymore. Like, what is the no for? I want to make sure that I am tracking where your thinking process is because sometimes the comments come in a little bit delayed and I talk really fast. And so there's that too. So let me know what that no, it does make sense. All right, perfect. So that helps me. All right, let's move on to problem number 2. Now you notice there's an A and a B. So that is, you're going to see why here in a minute. A ball is thrown up from a roof of a building. Its initial velocity is 20 feet per second. The equation H equals negative 16t squared plus 25t plus 80 can be used to model the height of the ball after t seconds. What does the number 80 represent in this equation? A, the vertex of the equation. B, the time it takes the ball to hit the ground. C, the height of the building. Or D, the maximum height of the ball. So problems like these trip people up all the time because they see this problem and they go, oh my goodness, I don't understand quadratics. I don't understand parabolas. This is a word problem. This ball is being thrown off a roof. I don't even know what's happening. And people start to panic. I'm going to show you how to read some of these problems so that you don't go into a panic. Even though this problem is for my 7 through 12, 6 through 12 people, the strategy I'm about to use applies to everybody. So let's go ahead and dive in. So we have this ball being thrown off of a building. And while it's important for us to understand the storyline, this sentence is what I like to call extraneous. It's not really all that necessary, other than knowing that if I was to draw a picture, here's my building, and here's some windows, and someone is standing up here, and they throw a ball, and a ball usually goes up and it comes back down unless I just chuck the ball to the ground. So a ball is thrown up from a roof. It's going to go up. It's going to hit a highest height and it's going to come back down. That highest height, the height of the ball at its peak, is going to be called our what? What part of a quadratic equation, what part of a parabola, what part of this picture is that called? That is called the vertex. Now, is that important information for this specific problem? Not really, but I need you to understand how to read what this ball is doing. And it has this initial velocity of 20 feet per second. And then they give us this equation. And y'all, when they give you an equation, it is the best day ever. They've just given you the problem and they've asked you, what does 80 mean? They've just given you the problem and they've asked you what 80 means. You don't have to interpret it. You have to interpret what it means, but you don't have to sit here and figure out what is the equation I'm going to use. Reagan, you're on the right track. You got it. So when they give me the equation, I don't need to freak out about this problem because I have the information. And so this is the height of the ball after t amount of seconds. So after 1 second, how tall is the ball? After 2 seconds, how tall is the ball? After 3 seconds, how tall is the ball? And then eventually we're going to get to a point where the answers don't make sense. Because what happens to the ball after we throw it up off the roof and it starts doing this? What's going to happen? What's going to happen? What's going to happen? What's going to happen? It's going to hit the ground. So eventually, the ball is not going to keep falling into oblivion. The ball is not going to keep falling into the depths of the earth. And so eventually we're going to get these answers that don't make sense within the context of the problem. Yes, if I draw this parabola, the range goes to negative infinity. The y values go down into negative infinity. Yes, that is 100% accurate. However, in the context of this problem, we are only dealing in the first quadrant. Because I can't have a negative height. I'm not in the ocean. Now, don't think we can never have a negative height, because if we are dealing with sea level, anything below that sea level would be negative. So don't think that that's a never. It's just a most of the time. And I'm also not going to have negative time. Negative time would be anything to the left over here, because my x or my t can't be negative. So I'm only dealing in that first quadrant. Now, I've gone way beyond the thought process for this specific problem, but I'm telling you, quadratics are one of the most popular, if not the most popular type of graph beyond a linear graph in those middle school and high school tests and areas. There's so much time spent on parabolas and quadratics and factoring and all of that, that understanding all of this is important for any other problem. And so in this situation, they've given us an equation after t seconds, and we don't even need the equation because it says, what does this number represent? What does this number represent? Well, if we understand basic operations of functions in general, we know that that is the y-intercept. How do we know that that's the y-intercept? Because in order for h to equal 80, this has to be 0 and this has to be 0 for us to equal 80, right? Like this whole thing has to equal 0, and so does this for me to equal 80. So if that whole thing and the other whole thing have to equal 80, then my time has to be 0 so that I can do 16 times 0 equals 0. 25 times 0 equals 0 plus 80. So 80 is my y-intercept. What is my y-intercept in the context of this problem? Well, my y-intercept is going to be where this graph is crossing the y-axis, which is that starting point at time equals 0, which is 80. So the ball is starting at 0 seconds at 80 feet high, which means that is going to be the height of that building, because then I'm throwing it and then time starts. It's not the vertex of the equation. It is not the height of the ball at the maximum. This is not the max. It's not the amount of time it takes the ball to hit the ground. First of all, I don't like to tell people to like think about it in real world, but if you're absolutely stuck, is it going to take 80 seconds to hit the ground? No, a ball is not going to take 80 seconds to hit the ground. And yes, we don't want to pull in our like real world knowledge because there are lots of times that that's not going to work. But if it's your only option because you don't know what to do, at least you can say that's probably not likely. And then the maximum, exactly, Reagan. I love, love, love that you noticed that. The maximum and the vertex are the same thing. The maximum height is the vertex, and the X value of that vertex is how long it takes for that ball to hit that maximum height. And so exactly, the maximum height is the vertex. So that's kind of a cheat way to see, oh, those two things are the same. I can cross them off because I can't have two of the same answers on this problem. It didn't say select all, select the two correct answers. And so that's kind of like a little fun way to be like, haha, beat you test. All right. So I talked about how this is problem A and that I'm going to have a 2B because then we're going to take this one step further. So same problem, different question. A ball is thrown from the roof of a building. Its initial velocity is 20 feet per second. All of that's the same. The equation is blah, 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 blah. Like we already have all of that, right? All of this is from the other problems. So we don't need to talk about that. However, what it does ask is, what is the acceleration of the ball at t equals 2? What is the acceleration of the ball at t equals 2? So let's go back to here and take our picture and just copy it over to here. Just so we can remember what this problem is looking like. So this problem, this specific chunk is definitely for my 6 through 12 people. K through 6 people, just check out for a hot second. Come back, don't go anywhere, but this piece is definitely for my high school people. We'll get to an elementary problem here in a minute. So I have my h of t function, which equals negative 16t squared plus 25t plus 80, right? And if I take the first derivative of that, I'm going to get my velocity function. And if I take my second derivative of that original function, I'm going to get my acceleration function. If you don't understand derivatives and you don't know what a first and a second derivative are, and you're taking a 6 through 12, 7 through 12 test, please know that it's not a huge, huge chunk of your exam, but that is a concept that is bigger than a Wednesday night math. So you'll want to schedule tutoring with myself or Priya. We are the math specialists here at the Learning Liaisons. Or you're going to want to like go watch some Khan Academy, some YouTube videos, because understanding derivatives to its core is just not a Wednesday night math topic. Understanding how to do basic derivatives absolutely is something we can do and we will do right now. So I am going to take the first derivative of my equation. So I'm going to use my power rule, drop the power, subtract 1. So 2 times negative 16 is negative 32 t. It's going to just be a t and not a t squared because I'm going to subtract 1 from the 2. And then this is an imaginary 1, so drop it. 1 times 25 is 25, and then 1 minus 1 is 0. And so that becomes a 0. And then this doesn't, you can't take the derivative of a constant. And then, so that's my first derivative. I need to take my second derivative. So I'm going to take my 1, drop it. Negative 32 times 1 is negative 32, 0. And then I can't take the derivative of a constant. So the second derivative of my height function is equal to negative 32. And then it asks me, what is the acceleration at t equals 2? At t equals 2, it's going to equal negative 32. It doesn't matter what t is. It's going to equal negative 32 because my acceleration function is negative 32. So just some basic like understanding of functions. This was kind of like something they used to throw us off, because once we got that acceleration function, the answer is just going to be negative 32 because I can't plug anything in for t. Does that make sense? All right, let's keep going. Reagan, you are killing it tonight. You are doing a great job. All right. Hey, I didn't even remember I had probability in here. So it is your lucky day, Shama. We have probability right here. Sophia has a bag of numbered cards. There are 12 cards in the bag, numbered 1 through 12, with no repeating numbers. She and 3 friends take turns pulling out a card from the bag and replacing it back in the bag. The first 2 people pull out an even number. What is the probability that the third person pulls out an even number? So the first thing I do when I'm dealing with this is I usually draw some sort of picture, especially if it's reasonable. And there's only 12 numbered cards. So she has a bag and there are 12 cards in the bag numbered 1 through 12 with no repeating numbers. That's important. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And these are all different cards that we have. And she and 3 friends take turns pulling a card out of the bag, right? And the first 2 people pull out an even number. So person number 1, let's pretend they pull out the number 2. And then the second person pulls out the number 10. But then there's a critical piece that they've told us. They're taking turns pulling the number out of the bag and replacing it back in the bag. So what that means is it doesn't matter what the first 2 people pulled out, because the probability that a third person pulls out an even number is not dependent upon what the first 2 people pull. Let's talk about what that probability means again. Probability is my desire over my total possible outcomes. My desired outcome is to pull out an even number, because they're asking what is the probability that they pull out an even number. Well, how many even numbers are in the bag? 2, 4, 6, 8, 10, 12. There are 6 even numbers. And I don't need to pull any of those out or not count any of those, because they're replacing them back in the bag. So they're not pulling the card out and then holding it. So what that tells us is that all of this is irrelevant. It doesn't matter. They're just trying to trick you. What are the total possible cards that are there? 12. 6 out of 12 is equal to 1/2. which is B. Hi, Natalie. I am so glad you joined us. Unfortunately, it started at 6. Our summer hours were 5:30 to 6:30, and now our school year hours start at 6 and goes until 7. But it depends on what time zone you're in. We start at 6 o'clock Eastern Standard Time. And so I know that kind of changes depending on the time zone that you're in. Some people are watching this at 4 o'clock in California. But yeah, 6 o'clock every Wednesday. So join us next week at 6 o'clock. But we're not done. We still have about 24 minutes. So you haven't missed. Oh, you're in Salt Springs. Sweet. You're in Florida just like me. So 6 o'clock. Where exactly is Salt Springs? I'm in Central Florida, like 40 minutes north of Disney. But I can't remember where Salt Springs is. So let me know. Just curious. All right, let's go ahead and go to problem 3B. Now, again, you'll notice it's going to be very similar like 2A and 2B were. Hey, Leah, it is good to see you, girl. I love seeing familiar faces. And you are excited to be here, and that makes me excited. Oh, it just disconnected. All right, we have to reconnect. You're going to watch the replay? Sounds good. How about you hang out and watch live for the back half and then only watch the replay for the beginning? Then we can hang out. Let's do that. I mean, you can do whatever you want, but that's my vote, is that you hang out for a little bit just so that we can all be together, and then you watch the replay. You need help with FTCE K6 math. Leah or Natalie, I got you. Every Wednesday we are here, and I will make sure that I have FTCE K through 6 stuff. I 9 times out of 10 have K through 6 in here, so you don't have to worry about that. Your test is this Friday. Girl, I am praying for you. You've got this. You have been studying so hard. And listen, everybody, give Leah good vibes while we're still connecting this screen. Give her good vibes. Tell her good luck. Tell her you're praying for whatever you want to say. I am praying for you that you do well. You've got this. I am confident in that. Okay, so 3A and 3B. The difference in 3A and 3B is just one small tweak. So let's take a look at that. Sophia has a bag of numbered cards. Still, there are 12 cards in the bag. Still, numbered 1 through 12 with no repeating numbers. She and 3 friends take turns pulling a card out of the bag and keeping it. The first 2 people pull out an even number. What is the probability that the third person pulls out an even number? Okay, what do you notice is different about this problem from the last? What do you notice is different about this problem versus the last? This is the only difference. Everything else is literally exactly the same. She has 3 friends in this problem. She has 3 friends in this problem. She has number cards 1 through 12 in this problem. She has number cards 1 through 12 in this problem. They pull out an even number in this problem. They pull out an even number in this problem. The only difference is instead of replacing it back in the bag, they are keeping it, which changes my probability. So I'm going to copy this, paste it in here. So now, and I'm going to copy all of these so I don't have to redraw it. Okay. So now, instead of a desire of 6 and a total possible of 12, now we have to remember that those people are keeping it. So the first two people pull out an even number. So it doesn't matter what even number they pull out of the bag because it's still going to produce the same probability because an even number is an even number. So now that this card is no longer in play and this card is no longer in play because it's in their pockets, how many total possible cards does that third person have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 total possible. And how many even numbers are there left? 1, 2, 3, 4. Simplify that down. 2 out of 5. So the answer is D. Do I know when they do the FTCE teacher professional exam? Reagan, I'm not entirely sure I understand your question. Can you help me understand your question a little bit better? And maybe that will help me answer you. I don't know what you're asking me. And Natalie, when I'm done, can I help you find some questions that help you for K6 math? So are you part of our boot camp? If not, there's a whole boot camp that I do that is specifically for K6. In fact, we have one for almost everything. So if you're not, I would suggest that. Number 2, I will absolutely make sure that I have a K6, K6 options next week. I think I have 1 or 2 this week, but I'll make sure that I have maybe 3 next week or 4, in addition to my, upper level math. So I will make sure that I have that next week. And then number 3, if you still feel like that's not going to be enough personalized help, you can always book a tutoring session with either myself or Priya on our website. And that allows you to get like personalized help for whatever you need. You can just, once you book that, you can reach out to us just to like be like, hey, this is specifically what I need. And that really goes for anyone in this room. So yes, while I take suggestions and I want to cater as much as I can to the questions that people have, I always like to give other options too. After I'm done, can I give some questions? You mean after I'm done tonight going over these questions? Because these questions are all like pre-curated and I come every Wednesday with pre-curated questions and we're done right at 7. So I'm not entirely sure what you're asking. If you want like provided questions, like specifically just like sent to you, that would come through our boot camp or through like tutoring or something like that. Shama, you've posted a question before. Please add that one too. Posted question by Shama. I will definitely go digging in our Facebook page and find that. I can search by your name. And so I'll absolutely go through and find that for you. All right, let's keep going. Let's do this one. Mrs. Miller gave an algebra test. The scores of the students are shown below, with the exception of one student who was absent. If Mrs. Miller wants to have a class average of at least a 75 on the exam, what is the score the absent student needs to score on the test? If Mrs. Miller wants to have a class average of at least a 75 on the exam, what is the score the absent student needs to score on the test? Okay, so this is an interesting one. This is one of those ones that we truly can solve algebraically, or we can use the answer choices to help us. So I have solved a problem like this before algebraically. So I'm actually going to solve this one using our answer choices because I don't think I've done that very often. So if I know they want to have a class average of a 75, at least a 75, what is the score the absent student needs? So how do I find average? Average is you add all of these things up and then you divide by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. However, we have an absent student also, and then I wouldn't have 9 scores. I would have 10 scores. So with that said, what is the score this student needs in order for the class average to be a 75? To use my answer choices, I can just take each answer choice, plug it in and solve, plug it in and solve, plug it in and solve until I get a 75 or close, like the closest to that. Now, with that said, here's a little test taking tip. There is no reason for you to take this and do 87 plus 62 plus 77 plus 94 plus 73 plus 81 plus 88 plus 76 plus 72 plus 40 divided by 10. And then 87 plus 62 plus 77 plus 94 plus 73 plus 62 divided by 10. And then 87 plus 62. There's no reason for you to do all of that 4 times. Whenever I'm using answer choices to solve my problem, and if you've been around for a little bit, you know this, I don't ever start with A. Because if I start with A, and then I go to B, and then I go to C, and the answer is actually D, then my brain just lost its complete train of thought. And my answer is D, then I've gone through A, B, C, and D, and I've solved it 4 times. However, if I start with B and I realize I need to keep going up, then I can do it only 2 or 3 times. But if I start with B and I need to go down, then I don't even need to solve A, or you could start with C. So I'm going to start with B. Reagan, yes. Okay, let me show you that. So I'm going to start by doing 87 plus 62 plus 77 plus 94 plus 73 plus 81 plus 88 plus 76 plus 72 first. 87 plus 62 plus 77 plus 94 plus 73 plus 81 plus 88 plus 76 plus 72. That equals 710. So now, anytime I go to solve another answer choice, I don't necessarily need to do 87 plus 62 plus 77 plus 94 plus 81 every single time. Reagan, yes, you're going to add all the numbers plus X, but you're going to divide by 10 because that absent student has to count as a score as well. So yes, the algebraic way would be to do 710 plus X divided by 10 equals 75 and then solve it. I've just solved problems like that before, so I'm trying to show how to use an answer choice. But yes, you just need to make sure you divide by 10 and not 9 so that you're accounting for that extra score. Okay, so 710 plus 40. Let's see what that gives. Oh, no, we're not going to start with 40. We're going to start with 62. I just didn't even follow my own advice. 710 plus 62. That equals 772 divided by 10 is going to give me a 77.2. So 62 technically gives me a higher average than what I actually need, which means 71 is going to give me a higher average than I need, and 75 is also going to give me a higher average than I need. So we're going to go back to 40. So now I'm going to go do 710 plus 40. Do you see how by doing 62 allowed me to erase all of those other answer choices? So there was no need for me to sit and solve a bunch of answer choices. Now, 710 plus 40 equals 750, and 750 divided by 10 is 75. So 40 ends up being the correct answer So had you done 40 first, you would have gotten lucky this time and not had to solve any others. But that said, when we're using answer choices to help us, we don't necessarily we don't want to start with A because we're not always going to get that lucky. Okay. Natalie, you missed it by 2 points. That tells me right there that you have the content knowledge. If you missed it by 2 points, you just need to brush up on some concepts and continue to study and practice for your date in September. But you've got this. Like, missing it by 2 points, that's like one question. You can do it. I am confident of that. All right, questions about this average problem. All righty, let's go ahead and move on to my triangular garden. This one is fun. Joelle is building a triangular garden where one of the sides of the garden will be the entire 8-foot side of her home. And the other side of the garden will be the fence that runs perpendicular to the side of the home. If the third side of the garden is 15 feet, what is the area of the garden? So, y'all, if you've been around for a little bit, you know I'm going to tell you, draw a picture. So, here I go. I'm going to draw my picture. She's building a triangular garden, so I need to have a triangle. Here is, and I don't want to just draw any old triangle because I want to pay attention to what kind of triangle this is. So it says one of the sides of the garden is the 8-foot side of her home. So here's her home, the back side of her home, and it's 8 feet long. And the other side of the garden is the fence that runs perpendicular to the side of the home. You got to know your vocabulary to know that perpendicular creates that 90-degree angle right here. And the third side of the garden, which I just have to connect A to B, is 15 feet. What is the area? So in order to find area of a triangle is 1/2 base times height. Elementary people, all of this so far could absolutely be tested. All of this so far could absolutely be tested. So K through 6 people, everything I've done up until now, you need to know. You need to know that the area of a triangle is 1/2 base times height. You need to know perpendicular and parallel and what the definition of those are and be able to draw something like this. The next tiny step you don't need to know, but then you need to know the rest. So in order to find my area, I know that this is base or height and this is base or height. This is my hypotenuse. It's not a base or a height, right? So I need to find that missing side. How do I find the missing side in a right triangle? A squared plus B squared equals C squared, where C is always across from the 90-degree angle. So A squared plus B squared equals C squared. A squared plus 64 equals 225. A squared equals 225 minus 64, 161. So A equals the square root of 161. And I'm kind of going fast through this because we're about out of time. So if you're confused on any of these steps, please say something in the comment box. So this is the square root of 161. Area of a triangle is 1/2 times base times height. 1/2 of 8 is 4 times the square root of 161. I'm going to use my calculator to find that. Square root of 161 is 12.6. So 4 times 12.6 is 50.75, which is C. Like I said, I just blew through that because we're running out of time. But I wanted to be able to finish that problem out. So for next week, I absolutely have K6 problems. I absolutely have probability problems. I absolutely have Praxis 7113. If there is anything else you need, please let me know. Leah, you have to tell me how you do on Friday. I will be praying for you. Natalie, I absolutely think that the the boot camp is worth it. It has practice questions. It has explanations from me. It has all sorts of stuff, but you're also talking to the girl who built it. So obviously I'm going to be biased, but I don't get a kickback for you like joining the boot camp or anything. And so me like speaking proudly of it is purely just me speaking proudly of it. I wholeheartedly believe in our boot camps. And so it's definitely worth it. If you have any other questions, let me know. I'm going to turn it back over to Dr. A, and I will see you guys next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.